First example we'll look at, find the extrema of this function f of x, 2x minus 3x to the 2/3 power, and the interval we're using is a closed interval from -1 to 3. So we're going to follow that procedure. We're going to find the critical numbers. In order to do that, first thing we need to do is know what the derivative is. So we're going to take the derivative of f. Take the derivative of f using those techniques that we learned in chapter 2. We get that. So we're going to find the critical numbers. So we're going to find out where is f prime of x equal to 0 or is not defined. So we set that derivative equal to 0, and when we solve for x, we get x equals 1. So that's one of our critical numbers. We also notice here we have a denominator. That denominator can't be 0. If it is, then the derivative doesn't exist. So when x equals 0, we have a derivative that's not defined. So we have two critical numbers, x equals 1, x equals 0. Now we're going to evaluate f at the endpoints and their critical numbers. So if we look back up at the interval we were talking about, up here, our endpoints are -1 and 3. Our critical numbers are 1 and 0. We have to evaluate our function at all 4 of those x values. So sometimes it's easier to lay this out and show the table. We have to show these calculations. We have to show calculating f of -1, calculating f of 0, calculating f of 1, calculating f of 3. The easiest way to do that is to lay that out in the table. All right, so we calculate those y values. We see here we have a y value of -5, of 0, of -1, of approximately -0.24. So we have our minimum at x equals -1. So we can talk about what the minimum value is. The minimum value is the y value. It's located at x equals -1, and it's located at the point -1, -5. So depending on what kind of question we're asked, we might answer the question in a different way. If it asks us what the minimum value is, if it asks us where the x value of the minimum value, or it asks us what point is at the minimum value, these are different ways that we can answer that question. And we look for the largest x value is here, so our maximum is located at the point 0, 0. And again, we might be asked what's the maximum value of this function. In this case, the maximum value is 0. And it might be asked what x value, or at what x value does the maximum occur. In this case, that would also be x equals 0. A function that uses, or an example that uses a trigonometric function. So find the extrema of f of x. We have 2 sine x minus cosine of 2x, and we want to find that on the interval from 0 to 2 pi, on that closed interval. So again, the process we use is exactly the same. The type of function doesn't affect our process. We need to take the derivative so that we can find the critical numbers. So our first step is to differentiate. To find the critical numbers, we set our derivative equal to 0 and solve for x. So you can see here I've used double angle formula, and then I can factor out the cosine, so I have a product. So when that cosine of x is equal to 0, this overall expression will be equal to 0, so that gives us cosine x equals 0. That means on this interval our x is pi over 2 and 3 pi over 2 on the interval from 0 to 2 pi. And setting the other part of the product equal to 0 gives us sine of x equals -1/2, and that's going to occur when x is 7 pi over 6 or 11 pi over 6. So here we found 4 critical numbers, and we still have the 2 endpoints, so there are 6 x values at which we need to evaluate this function. And so again, when we do that, we plug, or we substitute those x values, the endpoints and the critical numbers, into that original function, and we're looking for the y values of each of those points. So again, we lay out the table. In this case, we have more critical numbers, so the table is a little more crowded. But we have 0, pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. And we evaluate our function at each of those. So as we look for our minimum, we have a minimum at the let's see, we have a y value of -1. So our minimums, -3/2, are here. We have a minimum at 7 pi over 6, comma, -3/2. And we have another minimum at 11 pi over 6, -3/2. We have a maximum. I have a y value here of 3, so that's my maximum. So I have a maximum at pi over 2, comma 3. And again, depending on the question we're asked, we might answer this question a little bit differently. It might ask us, what is the maximum value on this interval? Well, the maximum value is 3. The maximum value is always the y value, or a minimum value is -3 over 2. It might ask us for the point, in which case we'd answer this way. It could ask us for the x values at which these maximums or minimums occur. Then we would just answer with the x value of the point.